Hello, everyone. Thanks for coming. Thanks for having me. My name is Phil. I work for a company called SoundCloud in Berlin. And I'm here to talk a bit about how we at SoundCloud have experienced, what's our experience with the Node.js community in general, and what I think, and this is not a SoundCloud thing, it's like what Phil thinks could or should be done to ease some of the pains we've had while trying to not only build systems in Node.js, but also get Node.js people to join us and to be productive and to write code. So the first thing, just briefly on me, in 2011, I decided that I didn't want to be a consultant anymore. I've worked in consulting with ThoughtWorks for 4 to 5 years. And consulting is very fun. You travel a lot, you build a lot of different things, but it gets to that stage where you earn that client for a year, and when things actually start getting good, when the product's out and users start using it, you are out of your contract and you're back home, and then you go back to another client and start over again and again and again, which kind of got me a bit tired, and I've decided that it would be better to go build a product. So I knew I wanted to go to Berlin and I literally went to berlinstartupjobs.com, which is a very nice website actually, and ended up finding this company called SoundCloud. So SoundCloud is the largest repository of audio on the web. We can think of us a bit like YouTube for the web. And the amazing thing is that when I first applied for SoundCloud, I actually have never heard of SoundCloud. But it happened the same as when my sister told me she was pregnant. She called me as like, oh, I'm pregnant, and congratulated her. I step out of the house, and immediately all women around me were pregnant. It's just you start realizing it. And the moment I applied for SoundCloud, I went to the Guardian page, I went to the Billboard page, and I saw that there were players from SoundCloud everywhere. We are a bit of a platform, we used to be. Now we are more of a destination website, but we grew as a platform. And we're fairly big. We have more than 8 hours of sound, music, and speech uploaded every minute, so you can't possibly listen to all of our archive, even if you stop for the rest of your life. And we have around 200 million users a month, both on our own properties, mobile websites, everything, and the other places where our widgets is, like the Guardian website, New York Times, White House, and different things. Yeah, we have from the White House, from Obama to Skrillex. We also have some weird stuff like the sound of bats having sex, which to me sounds very much like Skrillex. But it's a platform, and we are growing a lot. But one thing, coming from a consulting perspective, a consulting background, one thing I knew was really, really important to get right. I think when I joined, we were about 40 developers, and which is a big startup, but still small for the scale I was used to. And our recruitment process was a mess. I remember doing Skype interviews from London to Berlin, then flying to Berlin, doing the same interviews again, and then people not sure, so I had to come in a Sunday, and it was really bad. And I'm really passionate about recruiting and the whole recruitment process and sourcing as well, like finding people. Because I had this background as a consultant, and when you're working in consulting, what you do is to sell people's time. So sourcing, finding people is actually a core part of your business, because that's what you're going to sell anyway. So I came with this mentality, and I dedicated a lot of time with my team and the HR people in trying to get a recruitment process that would suck a bit less. And inspired heavily by what we used to do at ThoughtWorks, we came up with a very simple model. In this model, we have a fun interview where someone screens you just to make sure the expectations are matched. We got a lot of people who say, oh, I really want to work in audio codec, new format of audio codecs. This is not what a backend developer at SoundCloud does. We do have some people working on different parts of this, but if you're going to work as a backend developer, it's not very likely you're going to do that. So we need to set expectations beforehand. And the second part is the code review. So we send you a problem to solve. It should take about 3 hours for an experienced developer to do that. And we send it back. We have at least 3 people looking at your code and making an assessment. We try to give people feedback when the code was didn't meet whatever criteria we thought it should meet. And then if you succeed in that, then you come for interviews. And worst case scenario, you would have like 6 interviews. We've had higher with just 2 or 3. And an offer, that is the last stage. And as a manager right now, one of my main concerns is to make sure that this cycle goes very quickly, because it's really hard to find good people. When you find someone, you just want to make sure you get this person before the next guy gets them. And because I am also very worried about getting people that actually know what they're doing, I really, really value this step, which is the code review. To me, this is the most important thing. I can get along with you very well. Maybe we are not exactly the same kind of people, so we will have some rough edge to go through while communicating. But if I hire someone to write code and I haven't seen anything this person has written before, it sounds a bit off to me. So I tend to really, really value this part of the process. And one interesting thing we had is that when I first joined, this was literally the email I got with my challenge back then, which is to build a website with one thing. It's an upload button and a progress bar. So you could upload anything and have to make it available in a URL. And the only really trick on this coding challenge is the progress bar, because you have to synchronize that, and it has to work on IS6. So you have to synchronize that with what's being read in the backend, and it's a bit tricky depending on what you do, especially supporting multiple clients at the same time. But it's not too complicated. But yeah, that's what we had. And the first time I actually gave this talk, this is the second time, I collected some data on all submissions we've had, all submissions I've had evaluated, and tried to understand what languages people are using to submit their solutions in. We don't really require any specific language. SoundCloud used to be a Ruby shop. These days, we're moving more and more towards being a JVM shop, with a lot of systems in Scala and Clojure. But we never said you have to use this language or you have to even know Ruby. And the only constraint we had and still have is you should minimize the dependencies. Ideally, you should only depend on the language runtime. And that's a bit complicated with language like Ruby, where like everything's in the runtime. But you should not have to require a library. You may, if you think you really need this one library, but just write one paragraph explaining why you think it's needed. Anyway, so between 2011 and 2012, this was kind of the distribution we had. We had we have a lot of Ruby, a lot of Node.js, some Java, some C, some Clojure. And from these submissions, this is in percentages, the green represents people we actually invited for interviews after it. And that doesn't mean the person was hired, just that we actually said, oh, you know what, we should come to our office and we should chat. Before talking about the different values, one thing that I really, really hated that challenge. I hated it while I was making it, submitting my solution to it. I hated it while I was reviewing the code, because 99% of the case, it's so simple. Someone would get something like Rails, a Flash uploader, put them together and send to you. Sometimes there would be a whole project completely fulfilling what was asked. But there was like 1 or 2 lines of code that the candidate had actually written. Everything else was just putting together frameworks and doing some stuff. It got to a stage where I started emailing people back saying, hi, my name is Phil. I'm reviewing your code. I see you use the Flash uploader. I know we don't explicitly say that, but that's not kind of what we're looking for. Do you want to try again without doing that? Actually, it did work a couple of times. HR people were not too happy that I was doing that. But we got at least 2 people who submitted a much better solution once we were clearer with our constraints. But also, to be honest, the problem of uploading and streaming for us is pretty much solved. Transcoding is a bit of a pain because we have a lot of scale. But uploading and streaming back, we use CDNs and S3. So we have something in the middle that plays it, that just makes sure everything's fine, but it's stored there, it's saved there. We are as reliable as Amazon in that sense. So instead of doing that, we got together, like a lot of teams got together and tried to think of a better challenge for this. And the one we came up with was about events. So we're asking candidates now to do socket server. This is one system that people should build where it receives events in one socket, and events are user A followed user B followed user C. And events like user A sends a message or broadcasts a message. Who should receive? Only their followers. And your system just has to work out what's going on there. One thing we also provide is a test suite for you to check. So there's a program file that you run against your program before even sending to us to make sure that your solution is right or wrong. I don't have any problem talking about this here, and I wish to make this open source at some stage, because I don't really think these things should be secret or secrecy around this work. But anyway, then we got to our distribution. And one thing for this new challenge, and one thing is that, so over the past year, you see here, Go kind of took over from C. We used to receive a lot of C submissions. Now we receive a lot of Go submissions. I don't know how to read that. We do a lot of Go as well, especially in our infrastructure teams. So maybe it's because someone read the blog post on it. I don't know, but I think I got one submission in C over the past year. Everything else was around these languages. And once more, number of people who were invited over for interviews, it's pretty much like this. So Node.js is still very, very low in the number of people that actually make it to the second stage of the interview. And one thing that the first time I gave this talk, and when I talk about Node.js and our experience with Node.js with people, is that it's important to say, don't get me wrong, we are from Berlin, we are all hipsters. What we love talking about is programming languages, we love talking about frameworks, we love discussing to everything that you haven't heard of. It's so nice, and we do have Node.js projects. Actually, our mobile website is pretty much all the backend is based on Node.js. A lot of our event streaming website system was Node.js as well. But we were a bit scared because we were going for this new project, which was to replace our public API with in Rails, with something that pretty much just receives one HTTP request, makes 5 requests in the backend, mashes them together somehow and returns. This is the perfect case for Node.js, especially if you consider that everything is JSON. But we were like, can we actually build something with this tool and find people that can maintain and keep that going and growing in a good shape? Not too sure. We decided to actually build this new project in Clojure. But the main reasons that the code we receive are mostly like this. This is not actually a submission. This is something I got on the internet and trying to obfuscate because I wouldn't expose the candidate. But this is not, this is not functional. It's just bad procedural code. It's ifs everywhere. It's flags everywhere. And don't know what you're going. You don't know what you're doing. It works kind of. In each callback, there's a blob of JavaScript that's impossible to read, duplicated lines, blah, blah, blah. So the main thing I find in the Node.js community now, and the Ruby community as well, is that if something comes from some other language, Java, C#, Smalltalk is okay, I guess. But like, if something comes from another language, it's not good. No, dude, this is not Java. Don't try to push your complexity, your object models, your everything on us. JavaScript, Ruby, whatever, they are simpler language. They don't need that. And that code tells me that this is not true. That we shouldn't be throwing away years and years of development, culture, and sometimes even a little bit of science, just because we think our languages are simpler, we think our languages are better. So these are like some books that actually have some theory around how objects behave and how I design. And it's funny because I think most of them are in C++, and one in Eiffel. So we should be able to apply these kind of things, this kind of knowledge, kind of techniques, to our JavaScript code base as well, I suppose. But the main problem is that JavaScript is very flexible in the way that, especially Node, in the way that you can lay out your application. And I haven't seen a good book or reference on how one should lay out the application. One should create the major design. I think we evolved the industry in the sense that code and design are pretty much the same thing now. But the drawbacks that we stopped writing books and consuming material about design so much. Before, we used to have some more abstract books where modules talk to each other this way, were discussed. Now we kind of have a book on this library, a book on this API, but not so much on how to lay down an application. You have to spend a lot of time reading through open source code to understand how these people actually build this stuff. So the main thing about JavaScript in that sense, though, is that there's at least 3 ways to build a Node.js, JavaScript even application. One is to use decent procedures. One interesting thing about procedural code is that we keep hearing, oh, this is procedural, as if it was a bad thing. It's not necessarily a bad thing. There's a lot of people who invested a lot of time before most people in this room were born to understand and to create good patterns around procedural code. It is possible to do. You can spend your time reading books like this and then drawing diagrams like this, which you don't really have to. But this describes how modules interact with each other with flags and data, where they come and they don't come. There is a lot of technique, and there's a lot of patterns you can use when writing procedural code. Procedural code is not a blob of things put together in what should be a function and what should be a method. This doesn't have to be bad. But to be honest, it takes a lot of effort. The literature is not up to date in terms of technology, so you see like people used to draw a diagram like this, then write the code, then write pseudocode maybe, then write the code. So we don't do this anymore. It's a bit hard, but you could do it. You could totally do it. And the other option is objects. So everyone hates objects these days. Apparently, this is a nice thing to do. Even though I've been doing functional programming and Lisp languages for a bit, I really like object orientation, and sometimes that gets me to be the odd one in the room. I don't see any problems with that. I think it's fine. Obviously, the theory is flawed here, there, but then again, what's not? But you could do JavaScript with objects as well. In fact, our main website is a single-page app. There's a blog post describing it, which is pretty much object-oriented. And it's fine, it works well. We have a lot of people contributing to this code base. We have a lot of changes every day. Works fine. The code is readable. The code is maintainable. It's not Node.js, it runs in a browser, but you could apply the same principles somewhere else. But the way I like to write JavaScript, both in Node.js, but also in the browser, even though I do have much more experience in the back end than in the front end, is to use functions. And when I say use functions, what that means is, just like objects are the building block of an object-oriented system, functions become the building block I use. So everything, not everything, but most things are going to be modeled after functions. I'll show some examples later. But why would anyone use functions with JavaScript in that sense? Why not go for the object approach, which seems to be very popular? Well, the first thing is that it feels to me that the Node.js callback model, it feels much better. It suits much better functional approach than any other approach I've tried. This is the same with Ruby. One of the first projects I was part of at SoundCloud was our notification system, the thing that sends you push notifications, email notifications, and all that. And it's a system that processes a lot of transactions per second. And we decided to build it in Event Machine, which, if you know Ruby, if you don't know Ruby, it's an implementation of the reactor pattern. Because it was Ruby, we decided to make it really object-oriented, and we ended up with a lot of objects which implement the command pattern, i.e. they're just functions or procedures. And we wire them together, and we do a lot of things, and in the end, we're like, dude, if you just had made it a functional design instead of an object-oriented design, we would have saved a lot of lines of code and a lot of, oh my god, where does this go again? It just feels to me that especially the reactor pattern and the callback model suits a functional approach much better. And turns out that there is a lot of things online, including this famous post by Brandon Knight, the inventor of JavaScript, that says, oh, actually, JavaScript, I'm really careful what I say now, is a bit like Scheme. Because some people agree, some people disagree, some people kill each other after this. And as also someone who has done Common Lisp and Scheme a lot, I think they are. I think I can see a lot of Scheme when I write JavaScript, and I can see a lot of how I can make it follow Scheme patterns. And people think, oh, Scheme is extremely functional and this and that. Actually, Scheme has a lot of mutation everywhere. It just uses functions in a much better way. And I like to follow that. But I don't want to get into the religious wars of JavaScript is a Lisp, yes, no. I don't think it is a Lisp. But that doesn't mean that we cannot use what we know from Lisp languages in the JavaScript itself. How do we then use these languages? How do we get the concepts from languages like Lisp? I suppose you could use some other languages as well and apply them into JavaScript. As I said a bit before, I think it's fairly unfortunate that our industry got to a stage where we have code as design very well established in our heads, but we're not discussing design so much. We're discussing lines of code and 10 lines of code, but we're not. And also, maybe hang on, maybe I'm jumping from the 10 lines of code to how to distribute this globally in scale horizontally, but we're not discussing the mid-level architecture, how the modules talk to each other, how they should be shaped. I think we just decided that dependency injection is not a good thing, but then we didn't replace it with anything, and there is a lot of hard-coded dependencies being injected everywhere. And this, I really think this is a bit unfortunate, and we should work on that. But when I was thinking about this problem, how to structure an application in a functional way, someone suggested a book to me, which is free available online. It's called How to Design Programs. It's really good. And the way it guides you through many different things, but I think the gist of it, or what I would like people I work with and people who are applying for SoundCloud to take from it is stuff like this, this paragraph here, where it creates a function to add two numbers, right? So don't get scared with the parentheses. I swear it's the last time you see Lisp in this presentation. But what we have is something like this, and I apologize for it being so high. So this defines an add function. So it's defining a function. The add function takes an x, and then it returns a function called xAdder. So if you see there's another define block inside a function, the local keyword there is a bit like var in JavaScript, and then it returns this function. So you have a function that receives x, and returns a function that sums x with something else. If you run this into a REPL, that's what you get. You define, I'm defining my own variable adder, and saying that that's the content of add plus 7. Then I apply adder to 10, and I get 17. So if this didn't make a lot of sense because of the parentheses, it's roughly equivalent to this JavaScript. It's also very high. So if I get, I have a function add that returns a function receiving x, that returns a function that sums this x with another y. And then I create an adder and add it to blah, add it to blah. And here you have some Chrome output for it. Now, this is just using higher order functions and what is sometimes referred to as combinations to provide to add functionality to your code. And there are many different ways you can apply this. And this is like, I think this is the core of what that book and so much of the literature, especially around Lisp, kind of tells you. It's like write code this way, and you're going to have a lot of benefits. So what kind of benefits? Let's see 3 examples of how this can be applied to real-world JavaScript for some value of real-world, but how we can go old school, we can be cool, and still get some benefit. So first example, passing functions around. It is very, very common to have code like this in at least the code submissions I receive and the Node.js specifically code I've seen. These are 2 functions, add track and add user, which just receive a user and a track object and save them to the database or execute some operation in the database. What they do, they both get a connection, passing in credentials. They both execute, which in theory is a function that executes some SQL in the database connection, and they handle error. So obviously, there's a lot of duplicated code there. And because you may have one of these functions for each entity in your system, you end up with a lot of code. In object-oriented languages, you can deal with this in several different ways. The most common is to have a template method around this. But if you've used Spring, JDBC, and all that, you know that can get really, really bad. But also, you could try be fancy in object-use aspects for it, which never really worked very well, but still there. And different things. So to remove this duplicated code, even in an object-oriented language, is a bit hard. It's okay, it's doable, but it's hard. In a procedural way, I'm not too sure how we'd do that. But anyway, when you talk about functions and you talk about functional programming, there's an easy way to do that, or at least something that becomes easy after a bit, which is the first thing is that you extract what's common. And this is a pattern we're going to see over and over and over and over in functional programs. What you do in functional programs is that you extract the protocol, the interaction, from the what's actually being done. So what we're doing here is that we create a function, execute with connection, that receives a function to execute and arguments. And then it will create a connection to the database and just call that function or handle the error itself. That's very simple. That's very easy. We actually happen to do a lot of this stuff in the browser, but for some reason, not so much in the backend when writing JavaScript. But then once you've done this, you can write your add, track, and add user function like those. So they just execute, they just call execute, passing in the database, and the SQL they want to do. Your code base should be much simpler if you follow this pattern. And the way you invoke the operations like that. So you call execute with connection, you pass in the function. So when I was talking about function being the building block, that's what I meant. In an object-oriented design, you would be passing objects around. In a function design, you often be passing functions around. And sometimes these functions, well, oftentimes these functions are going to be pure functions, like this one, where it doesn't really change state. Well, it calls a function that changes state, but that's a different question. And it receives an argument. So this is, to be honest, out of what I've seen, including that sample I had before, this simplifies a lot of what people are trying to do around resource management. Why people don't do it, I don't really know. So another thing is that closures are not only for objects. In JavaScript, we tend to use closures to emulate object-oriented design. It's actually not a bad thing to do. A lot of languages do that. A lot of languages have the object system built that way. And there's this funny meme around an object is a Pullman closure, a closure is a Pullman object. This is okay, this is fine. But we can do more with that. Even if you don't want to use objects, you can use closures in a way that will help you build your program in a more functional way, even with pure functions, which are good for other reasons, but still have enough simplicity. So one example that also comes along, I haven't worked in any high-profile website that wasn't attacked every single day. I worked for a bit in a relationships website, that kind of find a partner, and that was the most horrific when it comes to being abused every single day by people trying to find the ex-boyfriend there and all sort of crazy stuff. In our case, we get a lot of spam. So what we do, if you go to SoundCloud.com now, and if you write some JavaScript yourself that makes, sends, 10 messages in a minute, you're going to receive a warning and say, hey, hang on, stop there. You're doing too much stuff at the same time. That's because we think you're a bot. We have a lot of people trying to sell plays and comments and sounds, and we have to fight against them. So that's the kind of code that one ends up writing. So the function write comment takes a count, author, and text. And if that count is bigger than 3, it just throws an error. It doesn't write the comment. Otherwise, it saves the comment and returns an incremented count. Why does it return an incremented count? Because I wanted to give this function pure, so I didn't want it to save state somewhere. So I'm doing everything I have to do and returning all information I had. There's no state cap, there's no state change, which is all very good and great, except that the way to call that function now is a bit like that in the block below, where I have a counter, start with 0, and then I have to manually keep the counter somewhere and pass it in. And obviously, this is an exaggerated example. This code could be everywhere. And how do you keep track of the counter? How can you make sure that the counter is always used, never erased by mistake? This is really hard to keep track of, but it doesn't have to be like that. One thing you can do is, first, you can keep your write comment code exactly like it is. Like, you don't need to change anything. It's OK. I would argue that keeping track of the counts and writing the comment itself are probably two different things, and maybe we should separate them in different functions. But you don't have to do it. Maybe this is another iteration in our refactoring. But what you can do is to create a second function, which I called here make write comment function, because I'm horrible at naming, that receives an author. And then what this function does is that it keeps two closures. It keeps an immutable closure for the author and a mutable one for the counter. And the function it returns is bound to the counter up there. So now you don't need to keep track of the returning value, because once you call this function, it will mutate the mutable variable. Meanwhile, your internal function is your write comment function is to pure, and it's probably easier to plug in some other things. One interesting thing about this design is that it doesn't. You can have the counter logic. You can abstract this protocol even further, and having the counter instead of doing write, making the second function instead of calling write itself, it just receives another function. This is doable, and that's probably what you want to do in the long run. But overall, it should be fine. It should work. And the way you invoke now is a bit different. So you create a variable current user writes comment, calling make write comment, passing in Calçado, and then every time you want to call, instead of calling that the first function, you call the function you just have in a variable. And the function, it works exactly like the one before. The state kept in a closure, it's a bit, you will eventually, depending on what you keep, you may have issues with that. For example, you can't as easy cache this guy, but there are ways of doing that. It's just a minimal example of what I mean by putting closures, having your state in the closures. And the third example, which is, it's a bit of a repetition of the previous ones, but with a bit more action, is using functions everywhere. You have a lot of this code as well, where you have delete user and activate user. And it's very common that an action like delete or activate I mean like when you receive an email saying please click here to activate your account. When you receive this kind of emails, we want to make sure that the person activating the account is either the user or someone who has access rights to do so. For example, an admin. And this literally in our code base, in our Rails code base, I think I've grabbed for this line over there, if current user blah blah blah, but in Rails. And I think whatever number of controllers we have, at least 2/3 of the controllers have this verbatim. Copy, paste, boom, copy, paste, boom, copy, paste, boom. We managed to extract with a lot of testing and canary releases, because it's Ruby, it's really hard to know when you change, it's Rails, not even Ruby. When you change something, you never know what's going to break. But we managed to reduce it and at least have them calling the same function. So now, instead of just having admin, we have like an ACL-ish implementation. But this is extremely common. And again, if you look at that, and if you remember the first example we had, probably what we should be aiming for here is to extract what's common, to extract the protocol. So we extract the common protocol with another horribly named function called make authorization checking function, which receives a function. So what this guy is going to do is that it's going to do exactly the same we had before, but instead of calling the exact function we want to do, approve user, delete user, it calls the function to execute if that was successful. And then again, once more, you could probably receive the list of users approved to do such and such operation. You could pass it in, or maybe even better, you could pass in an authorization function that does whatever to check what's going on. And then when you do that, your delete and activate user functions become to be a bit more like that. They're really small, and all they do is to actually do the task they're supposed to do, as opposed to a lot of plumbing and boilerplate. And how you use it is by the same way we've done before. You make authorization checking function, pass in the function you want, you receive a function back, and that's the function you keep using everywhere. One interesting thing that comes when you're talking about web applications is where do I keep these functions? Because if they're dynamic, how does that go? Per each request, I create these functions. I never really had problems with that. I've heard people, especially doing JavaScript in the front end, so for browser, having problems with these kind of things, and even having to cache functions and do a lot of different things. I'm not really a specialist in how to optimize JavaScript for the browser, so I don't know if this actually is going to cause you problems or not. For most of our infrastructure, this has never, in no language but Ruby, this has caused problems. In Ruby, because the garbage collection is funny, you have to do different things. But this works fine. And in the end, you can question yourself, do I even need these two guys up there? So when you start going this way, when you start separating the protocol, how things interact from the things themselves, you start having more, in my experience at least, a much more pure domain and description of what you're doing. The main problem with that is that, to me at least, that I don't know, because once more, we don't have really so much bibliography and work around how to design programs, which is the title of the book. I actually end up with some philosophical questions in my head about how to model an object, domain using functions too. Even though I've been using this for a very long time, I think I tend to fall back to the old object model and then try to pull me back up. We use a lot of Scala at SoundCloud, which kind of tries to mesh both object model and the functional model. I think it tends to drive you more towards the object model when you're doing domain modeling. We also do a lot of Clojure, which used to be very strict in what the data types are, as a functions and kind of structured data. But now it's much more flexible with protocols and things you can do. So I think the main problem with this approach is that there's no domain-driven design book for this. Some people try to think of that book I talked about, how to write programs as this kind of stuff, but I haven't seen any equivalent to this book, or like how to model your domain using functions, except when they talk about mathematical domains and things that easily align to functions themselves. But when we talk about user has a track has likes, these, and that, I haven't seen any good large example to apply straight away. So it's one. I think the main takeaway I wish you guys had was that there's a lot of times where we reinvent the wheel, and we all know that. I'm pretty sure every single speaker in this conference is going to say these exact words. We reinvent the wheel too much. But also, I think more than that, we think that what we have in our hands is different, while it's not. It's just we are fairly ignorant about what went on, before I was born. I know I am. And every time you're searching for patterns to build programs like that, because you don't know exactly what terms to search for, or what to Google for, really. It's really hard to find what's the equivalent someone used 20 years ago. My recommendation to that, just try to read books which are similarly useless to you at all times, like the structure analysis books. Probably none of you is going to use in your work, unless you work for a bank, maybe. But still will give you a lot of insight, and will teach you some words that maybe you can try to map back to your domain. But when it comes to Node.js and JavaScript itself, the framework we had there had only two things, or two techniques. Extract the protocol from what you're doing, and keep mutable state in closures. This is pretty much how I've been writing Clojure and Scheme for some time now. It works very well, and JavaScript also has been working for the past few years. I think that's good enough. But one interesting thing is that what I try to avoid in our examples and when discussing the problems is to use scary words like monads. Because what's going to happen is that you're going to start writing these codes like this, and eventually you're going to start thinking that actually your protocols also have a protocol. The resource allocation protocol for the database, that actually can be abstracted even further. And other stuff can be abstracted. And then you're going to go on Stack Overflow, and you're going to say, I'm thinking about this. And the first answer is going to be, oh, you should totally look at my mono tutorial. And you go look at the burrito tutorial, or whatever the guy had written. And it's going to take a while. You're going to finally understand. You're going to write your own mono tutorial, because that's the thing you do. And you're going to start actually using it a bit more. But you don't have to. You can start with just these two things I was talking about. Just extract the protocol from the actually thing that's been done, because that's going to be repeated over and over and over. It's a pattern per se. I don't think when you go more towards the functional edge, you need as many of the old school functional, object-oriented patterns anymore. Functional programming has its own patterns. Don't let anyone fool you. But you don't need those anymore. You will create another. The need for those will be fulfilled by higher order functions for a lot of them. And eventually you're going to discover some other patterns. And there's plenty to learn for. Like I was saying, most of these books, I really like owning books. I don't have a Kindle because I like the smell of books. And when I first moved from Australia to Europe, like the largest bit was 5 boxes full of stuff, these books. And I do recommend that you start buying and trying to read, even if you have no idea what you're going to use it for. Because especially like these tables, this picture is very rich. in the sense of stuff I myself bought thinking I'm never going to use it, but what the hell, I have it this weekend. And then eventually that mapped to my experience building systems in many different languages, even in Java, which I still do a fair chunk. You can see, at least you can understand why people are complaining about Java. It's like, that's why. But in JavaScript, Ruby, Python, Clojure, obviously, and Scala, there's a lot to learn from these books. Just don't be scared of the language they use, because sometimes they're written to a different audience. But go to Stack Overflow and have someone pointing you to the mono tutorial. But also, in the JavaScript community, there is some movement towards this now with _JS. So, because I had to repeat this talk, I started reading this book. And by started reading, I mean I placed an order in Amazon. And this is also full of interesting concepts and trying to escape from the whole, Haskell, Scala, category theory madness. You don't need that. You may need that. You probably will need that at some stage. But you won't need that to get your code to a much better shape now if you decided to go in a more functional way with the JavaScript. But then again, just to reinforce it, you don't have to do that. Object-oriented JavaScript is perfectly fine if you know what you're doing. Especially with Node.js, I don't think it's the best way, but there's plenty of people doing it. And funny enough, when I showed the graph, the two only people I've hired, I've made one offer, the guy hasn't replied yet, and the other one's been working with us for a bit 8 months now. The two only people who actually had Node.js submissions had them in object-oriented JavaScript. And it was fine. It was perfectly OK. They were great code, and we called the guys in. So yeah, this is what I had to talk to you about. So do you have questions? Time for questions? So I'll answer the why do you use Node.js at SoundCloud. If you have the other questions, just come grab me after. The reason we use Node.js at SoundCloud, it's funny because I'm talking to a lot of people from Twitter, Netflix, and different companies doing pretty much the same thing. And what we do a lot is to have microservices in the back and some sort of controlling API in the front. For example, we made a questionable decision of going with the public API for our backend for our website now. We are suffering a lot on that. If you go on SoundCloud now, open Firebug, press F5, and see the number of HTTP requests that are made, you're going to go crazy. One thing we want to do is to have these guys talking to a backend they own. And what this backend does is like one GET request here gets scattered across many different services. It's a bit of data flow programming, which is really cool. And then everything returns. Sometimes we don't care about if something doesn't return. We mash them together. We return one response to the browser or to the mobile device, which are even worse. Node.js is perfect for this kind of thing. It's just really, really good. You don't really have to think about this. A lot of the libraries are based on that. It's great. We started using it more and more, but then eventually, for this, eventually we hit the wall with hiring. We're finding people who actually could level us up in that sense, in how to use Node.js. And because we started becoming more and more close to what guys like Twitter, Tumblr, and other people are using, and Foursquare are using, we kind of moved towards a Twitter stack, which is Finagle as a framework built by Twitter, all these people use. That's pretty much what we're doing now. But one other thing we use Node.js heavily for now is segmentation of users, which is heavily based on events. Before, you had some sort of system where segmentation was what's the age group of this user, or I don't know, what kind of tracks this person has listened to in the past 6 months. In the kind of world we have today, segmentation has to be much more real time to know what to recommend to you, what to show to you. I really need to know what you've listened to 5 minutes ago. And for this, we are building a lot of our systems in Node.js, both those that try to get you to stay in the site and those that try to get you back to the site. Because obviously, as any public-facing website, there's a lot of people who sign up because they wanted to listen to one thing, and then they never come back because they even forgot what the website was called to begin with. And then you have to try to get these people back. And yes, this means spamming the hell out of them. We try not to. But these systems are built in Node.js these days. The backend for the mobile website now is being decommissioned and replaced with the other solution, with the Twitter stack I was talking about, just so that we have the same stack for everyone, for all of our systems.
Probably have time for one more question from Chris.
No one. Is functional JavaScript faster than object-oriented Node.js? I actually don't know. If anyone has a benchmark and wants to share, that would be great. But I don't think there are many reasons for them not to behave very similarly. But I never really had to measure this much. Maybe I get another one?
If you're doing them that fast.
What's the real difference between an object defining a function and a function returning a function? That's a very good question. Well, the object, I don't know if by definition, but I would say by definition, has multiple operations attached to it. And a function has only one operation. Function only does one thing. So a function that creates a function, it's just a function. It just happens that its return is a function itself. So while the object has a whole protocol attached to the data, and like language like Clojure try to make this a protocol instead of a class and object, a function just does one little thing. So it's much more, it's much less coarse-grained. And one problem that causes, which I haven't experienced so much in JavaScript, but I do experience a lot in Clojure, is how do you organize these functions? Do I put all my functions related to user in one namespace? Do I scatter them around by like what part of the horizontal layer they sit in? I don't know. This is still an open question in my head. All right. Why do my Scala applicants do so well? Actually, I think it is because they kind of know what stack we use. But I have to say that those who don't do very well, they're very horrible. But because you can find, well, if you apply for SoundCloud and you do your homework, you can find a kind of stack we use. So I think people tend to simplify. But we had some pretty good people being rejected in the process just because no one could understand the code they wrote. And the code worked fine and everything nice. But what the hell does that do? I don't know. Okay, thank you.